So we come again to a topic that I have to introduce to you as specialist maths students in Year 11 that you will be doing fairly soon in Maths Methods in Year 12. And that's integration. I have to teach you how to integrate. Now, I'm not going to teach you all the gory details. I'm just going to teach you enough that you can understand what we have to do in specialist maths. Part of the problem here is there's a confusing plethora of different words and even different notations that are used. I'm going to try and explain the main things to you. Differentiation is the process of going from a function to a function that gives you its slope. That's differentiation. Integration, sometimes called anti-differentiation, I actually prefer integration, but anti-differentiation is also used, is the process of going from the derivative back to what the original function might have been. Now I say might have been because they can be slightly different, but only in a very particular way. So have a look at this example. The derivative of 3x squared is 2 times 3, 6x. But the derivative of 3x squared plus 2 is also 6x, because the derivative of a constant is 0. And the derivative of 3x squared minus 7 is also 6x. Because the derivative of a constant is 0, when I'm integrating, when I'm going the opposite direction, I always have to take what I think the integral is and add a constant on. So I'm going to write, for example, the antiderivative, or the primitive is another word, or the integral of 6x is 3x squared plus a constant. And c is some arbitrary constant. It's your textbook is explaining just below. It's the constant of integration. It's the constant term. It's just a number you add on to the end. When you come to do definite integrals, I'm trying not to push you too much in one go. When you come to do definite integrals, you can work out what this constant is. In any given situation, if you're given some initial conditions, you can work out what this constant is. But if you're just asked for the indefinite integral, indicated by this notation, if you're asked for the indefinite integral, just remember to always add a constant on the end. Okay, what is this funny notation? This is an integral sign. It's actually a very big script S. S for sum. Now that link to summing we'll come back to later in the next kind of subtopic. We're starting with just indefinite integrals. The integral of this function with respect to x is some other new function called the primitive, or there you go, the primitive, or the integral, or the antiderivative of the original function, plus some constant. Some people write it, the integral of f dash, the integral of the derivative, is equal to the original function, plus some constant. You may even see it sometimes written like this, and sometimes we'll use this notation for our advantage. The integral of dy dx with respect to x is just y, plus a constant. Now, notice what this means. The derivative of an integral, if I start with this capital F of x, then integral of something, and I take the derivative of this, I'm going to get back to little f. The derivative of the integral gives back the original. But the integral of the derivative doesn't necessarily, because there might be a different constant term. So just be careful of that. They are, in some sense, opposite processes, but anti-differentiation, integration, results in adding a constant, because if I'd had a constant in the first place, it would have disappeared when I differentiated.